welcome to this lesson on Newton's law of motion. These fundamental principles describe how and why objects move. They form the foundation of classical mechanics and are essential in understanding engineering and everyday motion. Learning outcomes. At the end of this lesson, students should be able to first explain Newton's three laws of motion. Second, identify real life examples of each law. Background. Newton's law of motion, a fundamental principle that describes the relationship between the motion of an object and the forces acting on it. It formulated by Sir Isaac Newton. Newton's three laws of motion describe the relationship between force, mass, and motion. The first law explains inertia, the second law relates force to acceleration, and the third law focuses on action and reaction forces. Newton's first law states that an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is often called the law of inertia. Inertia means resistance to change in motion. For example, a soccer ball remains at rest on the field until a player kicks it. The force from the foot changes its motion. A swinging pendulum gradually slows down because air resistance and friction act as external forces. In a car, when the driver suddenly stops, passengers tend to lurch forward. This is why seat belts are important. They provide the external force needed to overcome your body's inertia and keep you safely in place. Newton's second law explains how force causes acceleration. It states that the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Mathematically, this is expressed as F is equal to m multiplied with a. In engineering, this law helps calculate the required force for mechanics. Motion examples in everyday life, such as pushing a grocery cart using a hammer, stopping a gas pedal, using a bicycle, launching a rocket, using a blender, swinging on a swing, and jumping. Newton's third law states that for every action, there is an equal and opposite reaction. This means forces always come in pairs and act on different objects. When one object pushes, the other pushes back with the same strength in the opposite direction. For example, when you place a book on a table, the book pushes down on the table with its weight, and the table pushes upward on the book with an equal and opposite force named normal force. When a gun is fired, the bullet moves forward while the gun recoils backward with the same magnitude of force. Next example, a boxer punching an opponent feels an equal and opposite force acting on his fist the moment of impact. Likewise, when a person steps off a boat, they push the boat backward while moving forward onto the jetty. These everyday examples shows that every action force is always matched by an equal and opposite reaction force. Let's look at how Newton's law are applied in solving problems through calculation. In every situation, we use Newton's third law to identify action and reaction pairs, and Newton's second law, F equals to ma, to calculate unknown forces or calculation. Situation 1, when two objects are on a horizontal surface and connected by a string. Situation 2, when one object is on a table and another one is hanging over a pulley. Situation 3, when an object is on an inclined plane and connected to another mass by a pulley. Last but not least, situation 4, when two objects are both hanging and connected by a pulley. In all these cases, clearly free body diagram, correct direction of forces, and systematic equations are the keys to accurate solutions.